In section 6.4, we learn how to perform mole-to-mole calculations within chemical reactions. So the first thing to recognize that in order to be able to do this type of calculation, we do require a balanced equation. If we have a balanced equation, we can do things like figure out how much product can be formed from a given amount of reactant. Here's a good example of that. So it says if 2 moles of methane are reacted with O2, how much water is produced? This is often phrased as being a moles of A to moles of B type problem. A is what we're starting with, where we know the amount of moles, and B is what we end up with, where we're trying to figure out the moles of B. So the key thing is to recognize that for every 1 methane, we can produce 2 water molecules. So to do this calculation is relatively simple. We're going to start with 2 moles of methane, and we're going to recognize that we produce 2 moles of water for every 1 mole of methane reacted. And so that means that we're able to make 4 moles of water from our 2 moles of methane. So it's not that difficult a process. If you keep track of all of your units and cancel, you can always check that you're doing everything correctly. Here's another one where we're reacting iron with oxygen to produce Fe2O3. And the question reads, if 3 moles of iron is reacted with O2, how much Fe2O3 is produced? And again, we can recognize this as being a moles of A to moles of B type problem. Iron is our A, and Fe2O3, what we're turning it into, is our B. So we're starting with 3 moles of iron. We're going to multiply by the conversion factor that has moles of iron on the bottom line because that's what we want to cancel out, and moles of Fe2O3 on the top line because that's what we want in our answer. The numbers that go into our conversion factor are simply the stoichiometric coefficients that appear in front of the respective formulas. So we're going to put a 2 alongside the moles of Fe2O3 and a 4 alongside the moles of iron. So 3 times 2 over 4 gives me 1.5 moles of Fe2O3 that can be produced from every 3 moles of iron reacted. Here's an example from the book. It says using this equation, 2H2 plus O2 gives 2 waters. How many moles of hydrogen react with 3.07 moles of oxygen to produce H2O? So let's write out what it is that we're trying to solve for. We have 3.07 mole of oxygen, so we know the amount of that stuff, that's our A, and we're trying to figure out the moles of hydrogen, that's our B. And it's relatively straightforward. We've got 3.07 moles of O2, and according to our balanced equation, we need, not 4, that would be wrong, we need 2 moles of H2 for every 1 mole of O2, because we have a 2 there, and while it's not written in, there's a 1 there. So you can see that moles of O2 will cancel out, leaving moles of H2, and we can go ahead and put that into our calculator, and it ends up being 6.14 moles of H2 that we could make. Okay, so that concludes our section on mole-to-mole calculations within chemical reactions.